Hello everyone, this is a video lecture for Pre-Calculus, section 5.3, trig graphs. So we did trig functions last time, now we're doing trig graphs, and they're doing the basics first. Let's talk about what, I guess you could say y equals sine of x looks like, or y equals cosine of x, mainly just sine and cosine right here. Well, sine basically looks kind of like, well, not like that. Like this. Let me try one more time. Okay, that's a little bit better. That's my sine. This actually is at 2 pi. Obviously, that's 0. And the amplitude, which I guess I haven't even given you a definition of amplitude. Amplitude is 1. Negative 1 to 1. Range there. I'll give you all those definitions here in a second. Let's just talk about it. Cosine starts up high, then goes down low, goes back up. But I'm going to try to make it look a little bit better than that. Oh, that's pretty close. All right. Again, this is at 2 pi. That's at 0, obviously. And yes, that's at 1 and at negative 1. Okay, now these graphs keep going. I mean, they'll keep going this way and all that. Forever and ever. This one keeps going. This one keeps going. They'll keep going forever and ever. So you've seen a sine wave that looks kind of like this. Forever and ever. And it goes negative as well. It keeps going both ways. Forever and ever. Harmonic motion. What I'm going to do, though, is just focus on the 0 to 2 pi aspect of these. The parts that I've drawn for you. Whenever I go and draw the next graphs coming up in the next questions. So, let's do a little bit. And I will give you definitions as we go, because the homework will give you definitions as we go. Y is equal to a times the sine of kx. Don't get too hung up on this. We're not going to sit here all day. Y equals a times the cosine of kx. So, amplitude is the number in the front, but the absolute value of it. They're going to be very picky and say it's the absolute value of the number of the front. So notice that whenever I had sine and cosine, it's just a 1, and therefore its amplitude is 1. Amplitude is basically that distance that it will travel from the average. So back over here, we got this distance, 1, and then 1. Yes, it's negative, positive. But that distance is always a 1. Period. Oops. If I could spell period, that is. Period is, in this case, we're doing formulas, 2 pi over k. Okay? I'm going to use different letters here in just a little bit because nobody uses k. We're going to use b. B is much better. But that's the formula there. So whatever k you have there, you put in the denominator of this guy, and you get your period. Period is how far it takes to get back to itself. How far it takes until you start seeing a repeat. And so here it's 2 pi, 2 pi. That's my 1 and my first period, and that's what I'm going to be focusing on when I draw this stuff. Okay. They have like a part B. I'm thinking of this guy because they'll do 6 sine of 2x. And so they want the amplitude. Well, that's 6. And they want the period. I didn't even spell it right. Period. Which would be 2 pi over 2. Which obviously would just be a pi. So we'll do that same stuff as we keep going through the rest of the problems in just a second. So first off, g of x is equal to 3 plus 4 cosine of x. And they want to graph it. They say, what's the graph of this guy? And we got a little extra stuff here. In fact, I don't really even like the way they've written it. It's 4 cosine of 1x plus 3. I like that better. Notice that we have an amplitude of 4. This right here is actually a vertical shift. Now this goes back to the algebra days where you can shift up or shift down Some things, that's a vertical shift of positive 3 going up. So I'm going to say up 3. Up 3. We're shifting up 3. And you can see that my period is going to be 2 pi over 1 now that I put that 1 in there. So just a plain old 2 pi. Also, it's a cosine graph. So I'm going to start up high and then go like that. So that's my basic graph there. Notice that I'm just simply going to keep my period at 2 pi. So this 2 pi over here, that's good. We like that. Vertical shift, we're going to go up 3. So 1, 2, 3 up. And its amplitude is much bigger. So it's like when its amplitude changes, it'll be like, much more distance because we're going 4 distance now from the x-axis. So let's try to piece all that together. First off, we're going up by 3. 1, 2, 3. And this is kind of like my average line, the middle line. And then I'm going to go up 4. 2, 3, 4. And this is where I'm going to start my cosine. Notice that I'm also going to go down 4. 1, 2, 3, 4. So this is kind of like the minimum and the maximum for my graph. And it will just go inside of that. You know what I mean? So I think that's it. There's not much else to talk about. So I would go all the way down here, and I go back up. And that still doesn't look super great, but you're getting the idea, hopefully. Okay, that's good enough. I'm better on a whiteboard, let's just say that. Not that I even use a whiteboard anymore, because everything's digital. And so we're stopping at the -1 down there, going all the way up to, I think it's 7 there. So there you go. Cool, it looks like that. Well, obviously it'll keep on going. It'll keep on going and going and going. It'll keep on going and going and going. I'm just focused on this first part here, and again, that should end at 2 pi, because again, that was my period. Okay, so let's actually do a real problem now with real stuff, and this is super, super important. First off, they're saying -2 sine of 4 times x plus pi over 4, and they want to graph that thing. Well, let me tell you, that's a lot more than what we just had a second ago, and that's why we have to now learn the proper way to make this stuff work. So this is my formula, okay? Y is equal to A times sine or cosine, either one's fine, of B times X minus C plus D. Now you can use different letters for some of this stuff. A, B, C, and D is super easy. My amplitude, we've already talked about, is the absolute value of A. Number in the front. My period is always 2 pi divided by B, that number. We have this new thing called phase shift, which is basically just horizontal shift. Okay, horizontal shift. Which is just C. But notice that my formula has a minus sign. Do you remember back in the day, inside opposites? Let's just say I had x minus 3 squared. Where's this shifting? Is it shifting to the negative side? To the left? No. That's shifting to the right by 3. It's going that way. Inside opposites. Okay, so that's just a little reminder on the side that we're going to opposites, therefore that minus sign is part of the formula. I'm shifting whatever that number is right there. So if I say x minus 3, well then I'm going to be shifting to the right by 3. If I said a plus sign in there though, that would be opposite, and we're going to be going to the left actually, inside opposites. Last bit, we got our vertical shift, which is just straight up D. There's no opposites there, just whatever this says, you go up or down that much. Okay, so those are my formulas. We did everything we ever needed. Now I'm supposed to decode this stuff here. Well, I actually have an amplitude equal to 2. Notice that, yes, there's a negative in the front, but they're saying the absolute value of that guy. Just 2. Looking at this guy, my period is supposed to be 2 pi over 4, so pi over 2 in the end. So that's definitely changed. My phase shift, notice that there's a plus sign in there, So we're actually going to be going a negative pi over 4. We're going to the left a little bit, okay? And we're not going up or down any. That's a plus 0 on the outside, so no up and down. Also, this is a sine. So we start with our sine graph, and we are going to take that negative into account here in just a second. That's going to be a vertical reflection. But that's not used in the formula for some reason. They just assume you know that. Whatever. So let me start with my graph. Sine looks kind of like this. Oh, man. I'm trying really hard. Okay, that's good enough. And so, again, we're going all the way out to 2 pi. This is my sine of x. Well, first off, I know that we have a negative sine of x. So what's going to happen is it starts going down and then back up. Notice also that my graph is a negative 2 sine x, right? Negative 2, the amplitude's 2. So we had it right there. Somehow that's even better than my normal graphs, but we're going to double its height. Doubling its height. That means more amplitude, bigger, both positive and negative. And now, so what we've done so far, we've taken care of this part, sine, but we haven't done any of this phase shift or the period stuff. I'm saying that I'm going to start here at pi over 4, negative pi over 4, and then I'm going to go to pi over 2. What's interesting in this pi over 2 is technically pi over 4 plus pi over 4. If you think on degrees for just a minute, I'm saying negative 45 degrees, and this is 90 degrees. Isn't 90 made up of two 45s? 45 plus 45, essentially. And so I'm going to go backwards of 45, and then I'm going to go forward the whole length of 90, which ends up being a positive 45. So in a way here, I'm saying that I'm going to do my last little graph here, okay? I'm going to be going backwards to negative pi over 4. I'm going to draw this thing. So it's going to do a big swoop thing here. Swoop. Actually, I don't really like that. I'm going to do a little differently here in just a second. Hold on. I know I'm not going to make it perfect, but well, you know, I'll do my best. Okay. That distance that I've traveled here is pi over 2. So do the math here. Got negative pi over 4 plus pi over 2 actually makes a positive pi over 4 is my end. I stop my first period at positive pi over 4. So I'm going from negative pi over to positive pi over 4. Of course, that doesn't look any better like a 4. Look better just me doing that. Okay, that's my graph. There we go. Of course, it'll keep on going forever and evers and whatever like that. But this is the main focus. If you can get this part down, you're good to go. Again, all of my graphs are not perfect. I'm just doing the best I can with drawing it and stuff like that. 53042. Y is equal to 1 plus cosine of 3x plus pi over 2. What I need to do is decode this thing. Do you remember the formula for this? A cosine of b times x minus c all plus d. Do I have that same formula? Well, no. This guy here's got to go to the back. So that's one of them. Notice that I don't have a set of parentheses on the inside. I just have a plus sign, and somehow I'm supposed to magically understand. You need this parentheses set. You must have it look like this. If you don't, it won't work. So what do? I'm going to say 1 cosine of 3 times something, x something rather, and then plus the 1 on the outside. I must have this set of parentheses here, otherwise my formulas don't work. They just don't. I'm going to ask you, what's your phase shift? And you're going to be like, I don't know. So I'm doing this so I can get the proper phase shift. If I pull a 3 out of this guy to the front, that's super easy. But what do I do if I pull a 3 out of this guy? So this is what I'm doing. I'm saying 3 over 3. And I want the 3 in the numerator to come with me. What's left in the denominator is a pi over 6. Now this is also interesting. I must have a minus sign here for my formula, but there was a plus sign in between these guys. How do I make a plus sign out of a minus sign? I'd have two negatives. Make a positive. So now you can see your C. It's funny how that works. Haha. There's a B. There's my A. My D. There you go. If you're unsure about how I did all this, because it was a lot, I would go backwards. Distribute. Simplify. You tell me, did I get the original correct? So now I can actually graph this thing. Well, first off, I'm starting with a cosine. So I'm starting up high and going down low, something like that. That's my cosine x. I don't have to vertical reflection or nothing like that, thankfully. I don't even have to change my amplitude. But I do need to shift it up by 1. So I'm going to go ahead and do that right now. So shift it up by 1. This was at 1 right there. This is at 1. So I'm shifting it up quite a lot. And I'm now here at 2. I'm going to do this. Something kind of like that. Okay. 1 is now like the middle that we have. My period, just kind of writing in the lines here, is equal to 2 pi over 3. So I'm saying that my total distance here must be only 2/3 distance. Whatever that means. And then my phase shift, that number here, notice that, again, I originally had a positive, so we're actually going left, we're going in the negative land. You can see that this number here, C, is a negative. And so that's a shift to the left by pi over 6. So exactly where pi over 6 is and all that stuff, I'm not going to be perfect with it. I'll try. So that's my 1. Let's just say negative pi over 6 is about right here. And I'm going to go a full distance of 2 pi over 3 from this starting point. I start up high and work down low. Here we go. Something kind of like that. Again, this will keep going forever and ever, whatever, but that's the main part of it there. Okay. Where exactly does this end up? Where is this end mark here? Well, it's negative pi over 6 plus 2 pi over 3. You can do the math if you like. To get this into a divide by 6, I would then say this is 4 pi over 6 minus 1 pi over 6 makes a 3 pi over 6, ends up being pi over 2. So that is my end. Like it literally right here. What is that? That's pi over 2. You can do the math on the side if you want. That's up to you. As long as you're getting this part here, that should be most of what you need. So one thing before we keep going, because I don't have very many more questions left. We're getting near the end. They're going to offer you multiple choice graphs on these. Suppose that you got 4 graphs to choose from. You got 3 chances on the homework questions, let's say. So you could technically get it wrong, but eventually if you keep clicking, new randomization, clicking, new randomization, eventually I would hope that you get something correct. You can just blaze through the homework and get everything correct without ever thinking about it. But that would be a disservice to you. You're not learning then, you're just playing the system. So, you know, if it's last minute and all that stuff, I'm not going to ever recommend it. I'm still saying don't rush through this. This is something important because we'll be doing this later in the class as well. In fact, the next section is just more of this, but way harder. So better learn it now so that you're good for the next sections, you know. And that's just the immediate future. Just think of what's coming up, like even in calculus, because I'm supposing you're going on the calculus. 53048. And so this time they give me a graph. It's kind of backwards, it seems. Looks kind of like this here. That's definitely not perfect. I'm going to try one more time. That'll work. And it'll keep going and going. This is at 6. This down here is at -6. And they say over here it ends at pi. My first period ends at pi. And they have to tell me that this is a cosine curve. If they don't say that, then I'm honestly a little bit lost. They're saying that in the end, I'm going to have blah, 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 cosine, blah, 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 fill in the blanks. So let's actually fill in the blanks as best I can here. What's my amplitude? My amplitude, again, is that distance here. It's a 6. Okay. What's my period? Remember that period is 2 pi over b. And my period in this particular case is a pi. So there's your answer there, by the way. But I can now use this to find out what my b is. So, okay, 2 pi over b is equal to pi. The pi's actually cancel. You got 2 over b equals 1. Move the b over. B equals 2. So you got an a equals 6. A b equals 2. The phase shift, horizontal shift, whatever you want to call it, is, if this is cosine, and, well, cosines generally just look like that, is it shifted any side to side? Has it shifted any? The answer is no. So I'm going to say a 0 for that. No shift. And vertical shift, oops. Well, that happens. Vertical shift, did we have any of that? I would say no, 0. Okay. I think I still have it too zoomed in there. That's good enough. Okay. So now what? Let's go and construct. So y is equal to a times cosine of b times x minus c all plus d. Well, a lot of this stuff is already a 0. 0, 0. So that's a lot easier. Amplitude was 6. A, 6. B is equal to 2. And there we go. I'm actually done. That's it. Okay, I got 2 more problems, but they're just different. These are way different, and I'm glad to do them with you, of course. They're just different. So 5, 3, 0, 7, 8. I've got tangent of x is equal to 6. Solve for x. Tangent of x equals 6. Solve for x. Well, that's strange. What do I do? And they even say on the interval of 0 to pi. Well, whatever. That's fine, I guess. So what is my answer here? Well, what I actually have to do is I need to use a calculator. And by calculator here, I mean scientific calculator. X is actually going to be equal to the arc tangent of 6, which we'll find here in a second. That's the arc tangent, or just arc tan, or just a tan. They're all synonymous, depending on what you're talking about, I guess. What language you're talking to people. It's arc tangent. That has a little -1 up here. This is not the same as saying 1 over tangent. That is not the case. I know that often with a -1, we're thinking, oh, it's like a fraction. We're trying to say inverse here, okay? We're trying to say inverse tangent. Well, there's a button on your calculator, and if you have like a phone or something, you can turn it sideways, and you'll get tangents and arc tangents and all that kind of stuff. Make sure that you're in radian mode, because we're talking about radians here. So make sure you're in radian mode. And I'm just going to try it here myself. Ooh, I was in degree mode. Change it. Arc tangent of 6, and I got... Oop, I don't need to put an equal sign there. So I did this in my calculator, and I got 1.405647, etc., whatever. And that's actually your answer. You're done. That's it. So not hard. It's just kind of weird. So arctan, there is a button for it. It's typically on top of the tangent button. So like you're looking at it, you got to hit like shift tangent or second tangent or something like that, and it'll come up with this little -1 inversey thing, okay? Last question. So I've got y is equal to 6 sine of x plus sine squared of x. And I would say, I know. They're saying find the maximum value and the minimum value. Now what they're talking about is y values. Find the minimum and maximum y values. How high and how low can this thing go? Could you graph that and just look at Desmos or something like that, or your calculator? Sure. That's not the point here. Can I find it some other way? The answer is definitely yes. This right here, this section, this 6 sign, actually has a range. Again, range means y values of -6 to 6, right? That's my amplitude, 6. This guy has a range that's kind of different. You ready? It's actually 0 to 1. Now, normally I would say -1 to 1 for a sine, but because I'm squaring it, here, square both of those numbers individually, and I would get a +1, +1. Is your range always a 1? Are you always having a 1 answer there? No. What's going on is that there are some times when it's 0 as well, and 0 squared is 0. The graph of sine squared basically looks like this. Pretty sure. Yeah, I think so. Anyways, regardless, it looks like that. So you're going up to 1, no lower than 0. This guy's all over the place, though. Who makes the biggest changes out of all this stuff? And it would definitely be this guy. He's huge. -6 to 6. So I'm expecting answers here kind of like 6 and -6. Those are my guesses there. Well, then my range here also affects it. I'm basically saying this guy plus that guy, and I should get an answer. Well, 6 plus 1 is 7, and that's how I'm going to get my biggest range. Well, now you're thinking, oh, well, -6 and a 0 should just be -6 then, right? Well, no, hold on. The answer is actually -5. The reason why is because it's that -6 and the +1 put together. So you did 6 and 1, and then you get -6 and 1. Why do you ignore the 0? It's because every time that you have the 6 sine x at a min or a maximum, your sine squared, it always equals a 1 there. Okay, like this guy right here is equal to a positive or -1. Well, guess what this guy is? He's a positive or -1 squared, which always results in a 1, a +1. And so, in a weird kind of way, I'm always saying this guy is going to be a 1 for me, as long as this guy's -6 and 6. And so I just go +1 in both of those cases. Still, this might be a slight bit confusing, and so I would recommend graphing it. I had mentioned it earlier. It's not a problem to actually graph any of this stuff. I think it's a good thing. Just don't rely on it all of the time. You're using it as a tool. There are homework questions where you need to use a graphing calculator. Do it. This is probably one of those. I mean, it wouldn't say it's required, but it definitely helps. Okay, I think that's about it. So if you have any questions, let me know. Thank you very much. Have a great day.